Testing the V1 saliency hypothesis by a V1 model, Part 4.
In each of these three visual input images, only one bar is tilted 45 degrees from vertical. All other bars are less tilted from vertical. This unique 45-degree bar appears most salient in this image, so it will be quick to find it in a visual search task. But the same bar is less salient in these two images. Here, all background bars are 15 degrees from vertical and spatially regular. It has been known that a feature singleton is more salient when the background is homogeneous. In this image, the background bars are randomly placed, although they are uniformly oriented. Here, the background bars are randomly oriented around 15 degrees, although they are regularly placed. Our V1 model responds like this to these images. The responses to the unique bars are inside a circle. Here, this response is higher than all the background responses, and all the background responses are very similar to each other. This makes the z-score for the unique bar quite high, 3.4. Here, some background responses are higher than the response to the unique bar, and the responses to the background bars are more heterogeneous, so the z-score for the unique bar is quite low. Similarly here. Homogeneous background gives homogeneous background responses because iso-orientation suppression acting on the background bars is also homogeneous. However, the iso-orientation suppression is not as homogeneous in these two cases. Different background bars are surrounded by different contextual inputs. For example, this bar has fewer neighbors, so is under weaker iso-orientation suppression. Here is a simple example of visual search asymmetry. It's easier to find a cross among bars than to find a bar among crosses. Here are the search targets. The V1 model's responses agree with this. At the target cross, the z-score is 7. At the target bar, the z-score is 0.8. The horizontal bar in the cross is uniquely horizontal, so it escapes the iso-orientation suppression from the neighboring vertical bars, evoking a relatively higher response. The target bar is not uniquely vertical in this image, so it is under iso-orientation suppression from the neighboring vertical bars in the neighboring crosses. For the z-score in the cross, the response to its horizontal bar alone determines the z-score, not the combined responses from two neurons, one for each bar in the cross. This is because by the V1 saliency hypothesis, a location's saliency is determined by the highest response to this location. Let's also notice that here there is no need for V1 to have neurons tuned to a cross shape to make this cross's location salient. Our model has just neurons tuned to bars only. So in principle, V1 could be responsible for more complex visual shapes to attract attention exogenously. Here is an example of a feature search versus a conjunction search. In this image, try to find this target shape among these shapes. It's quite easy because the target has a unique horizontal bar in the image. In this image, try to find the same target shape among these two shapes. It's quite difficult because neither of the two bars in the target is unique in the image. The conjunction of these two bars makes the target unique, so it's an example of conjunction search, which is known from visual search literature to be typically difficult. Each bar in the target is under iso-orientation suppression from neighboring bars sharing its orientation. V1 model's responses agree with visual search behavior. The feature search target has a z-score of 3.3, but the conjunction search target has a z-score of -0.9. These four examples demonstrate that the saliency of a texture border depends on the density of the texture bars. Each of these four images contain two neighboring textures with a vertical border between them. Each image has a left texture containing vertical bars and a right texture containing horizontal bars. However, the texture border is the most salient in this example, still quite salient here, much less salient here, and least or not salient here. The V1 model's responses agree with these observations. The responses to the background bars are less suppressed when the texture bars are sparser, because each bar has fewer iso-orientation neighbors to give iso-orientation suppression. The z-scores of the texture borders follow accordingly. It equals to 4 here, 3.3 here, but only 2.1 here, and 0.57 here. This image contains a homogeneous texture with just a single bar missing, creating a hole in the middle. This hole appears also somewhat conspicuous. However, one must wonder which V1 neuron is signaling for the saliency of this hole if there's no bar to evoke responses from any V1 neuron to this hole. However, each of these two neighbors has one fewer iso-orientation neighbor to exert disynetic suppression compared to most other bars. So, relative to most other bars, they should evoke slightly higher responses. Although their responses may be only a small fraction higher, this fraction could be sufficient to give their locations high z-scores for attentional selection if the background responses are sufficiently homogeneous. Attentional attraction by these two neighbors could feel like an attraction to this hole. To visualize small variations in the V1 model's responses, we use gray levels to represent the V1 model's response levels. The response is 0 to the hole. The responses are highest to the neighbors, giving them a z-score equal to 3.9, making the region around the hole quite salient. As a comparison, let's put an orthogonal bar inside the hole. It is much more salient. Of course, the V1 model's response to this orthogonal bar overshadows its responses to all the other bars, and the z-score is 18.
Here is another example where neighbors help to attract attention. Try to find a vertical bar among crosses in this image and also in this image. The target is easier to find in the image on the right. In both cases, the target bar is under iso-orientation suppression from background vertical bars and in fact have negative z-scores. In the image on the right, the horizontal bars above and below the target evoke slightly higher responses because each has one fewer iso-orientation neighbor for suppression. They give a high z-score of 3.7 because the background responses are quite homogeneous, so a response only needs to be slightly higher to give a high z-score. But in the image on the left, the most salient neighbor's z-score is much lower because the background responses are more heterogeneous. Here, two neighboring textures are identical to each other. We can easily segment them by some salient border bars. According to the V1 model, the bars evoking slightly higher responses are these on the border. These bars have somewhat different contextual surround compared to the texture bars away from the border. So even though their evoked responses are only slightly higher than those from the other bars, they could still give high z-scores when the background responses are sufficiently homogeneous. Here is another example. Now, the most salient border bars are one column away from the border, and their Z-scores are also high for similar reasons.
We may wonder why aren't these border bars evoking higher responses than the bars in the neighboring column. This is perhaps because these border bars are under a weaker collinear facilitation due to a slight change in the spatial arrangement of their neighbors. Nevertheless, attention to bars one column away from the texture border also brings attention to the border, as long as the attentional spotlight is not too narrow.
Here is another example in which some texture border bars are salient by having different contextual surround. In each of the two neighboring textures, we have bars tilted 45 degrees one way or another from vertical. In the left texture, the bars are grouped horizontally. In the right one, they are grouped vertically. The V1 model's highest responses are to these bars on the border. Indeed, the texture border seems more conspicuous than other image locations. Here is the visual input image above the model's highest response locations. These are 3 additional examples and their respective locations to evoke highest V1 model's responses. These locations correspond to our experience about where the most salient locations are. In each image, try to understand why these locations evoke relatively higher responses. In this example, these locations are under collinear facilitations in the V1 model.
In images A and B, the highest responding bars are these ones, and we can see that they have contextual surrounds to give them good collinear facilitation, but weaker iso-orientation suppression.